I am Burak. I'm coming from Berlin. I'm not from UK. I'm actually. Oh, where's the clicker? Can I get that one? Thank you. So let me give you a small introduction. Which one should I click? This one? Yeah, it works. Okay. So let me give you a small introduction. My name is Burak. I'm living in Berlin. I moved there 3 years ago. I'm actually originally from Turkey. I moved there for a tech job, and I'm living there. I'm quite enjoying it. I love cold weather, and Berlin is the best place to do that. And you can see me here jumping in a frozen river, which is a quite high place that people drink their alcohols, even it's minus 10 degrees. It's fine. So one of my biggest hobby is walking and drinking beer, and there is a term called Weg beer in Germany, which means literally when you translate it, it's a beer on the road. So you just grab a beer and walk to anywhere. And I'm having some struggle with learning German because it's really hard. You can see that I have this is a screenshot from this morning, actually. I have a 578 days of streak, but I'm still A1, so it's not, I don't know German. So it's just like, I'm just keeping the streak, that's it. So today, as I said here, it will be a talk about asynchronous code execution under the hood with JavaScript. How many people are here front-end developers or working with JavaScript? Okay, quite a lot. Okay, that's really cool. Even if you're not interested with JavaScript, it might be interesting for you because this will be a talk that we will see how things work under the hood with the browser and the JavaScript code. It will be a little bit boring, but try to keep following me because I think it's a really nice piece of knowledge that you can grab to see how things work in the background. So, okay, so I have this question. Do you think JavaScript is a synchronous language or asynchronous language? If you say synchronous, can you please? Okay, perfect. Okay. So the minority says it's a synchronous language, and it's a synchronous language. It's not an asynchronous language. There's just one thread in the JavaScript. So you can just run one line of code and one task at one time. So you cannot do double of stuff. How do we fetch some data? How do we get some data? So this is the tricky part, actually. You cannot do this just by JavaScript. You need help from some other resources. And we are using browser to help us with this one. So since modern apps are fetching lots of data and getting lots of data, we are seeing lots of loader screens in our browser apps. And in this browser apps, while you are seeing the loader screen, you are getting some data, you can do some other stuff. And in the meantime, you are not getting blocked. We have one thread, we can execute just one thing at one time, but we are managing it in a way to run multiple tasks at one time. If we just could only fetch data synchronously, it will be a disaster for us because in the meantime, you are fetching the data from a remote server. You couldn't do anything. The UI would be blocked. You cannot type anything to an input. You cannot click on any boxes. You can even not see any hover effect when you mouse over the buttons. So I hope the people at the back side can see it, but if not, please feel free to come here. And so this is a performance test when you do a performance test in your browser app. So here you can see this is the ideal version. So there are lots of sticks, which are very, very, very thin sticks. And these thin sticks are showing how many times did we block the thread and how long we did block the thread. So it works like this. So whenever you do a task, you are running something on the thread. And when you're running something on the thread, it should be short so that you can run other tasks. You can do some typing, you can do some clicking on the buttons and stuff so that you cannot block the thread. So all of those thin sticks are just like 1 millisecond and even lower than 1 millisecond. And when you have something like this, the human mind cannot understand that, cannot see that this 1 millisecond of blocking of the page. So we feel like it's not blocked. Actually, for that duration of time, it's a blocked, but we don't accept this as a blocked. So if we had a XHR request, a request to server, which was synchronous, and let's say that it took, I don't know, 2000 milliseconds, which is 2 seconds, which is a normal time sometimes if you are fetching a big data, sometimes it can happen. Ideally not, but in that case, you would have a huge block at the thread. And this time, nothing can run. You cannot do anything. You cannot interact with the UI. It's just frozen. So this is why having the support of browser is important. And I will show you now how this works, how browser executes our code. But before that, I need to show you what is execution context. So here you can see we have a script, which is a super simple one. We have a number here, we have some functions, and then we are running those functions. So here, each function has their own execution context. And we have the global execution context, which wraps all of them. You don't need to know much about this, but just keep that in mind. If you are in an execution context, you need to finish it first so that you can run another execution context. So here, just keep that in mind for the next slides, that each function will have their own execution context. And now we will have 6 code snippets, and this is the first one. So this is a snippet to show how I will run the code line by line, and to get you guys used to the processing method that I will do, how I mimic the browser while I'm doing this. Let's go. So I have a huge chart. I'm really sorry for the people in the background. So if you want, you can still come front because it might be a little bit tiny. So here we have our memory. Here we have 2 queues. I will come to that. We have our browser tasks here. We have just some kind of like a notepad. We can do some like writings and stuff. We have our console here, which is mimicking the console that we have on the browser when you do inspect. We have our call stack. The stack is just like a stack, the last in, first out stack. So if you push something to here, you need to finish that stack first. And afterwards, you can continue the rest of it. So here, the first line, you can see the red dot here. The red dot means that we are executing that line. We are at the 0 milliseconds. So in the first millisecond, we will just define a prefix variable to the memory. The value of it is high. And then name, it will the value of it Burak. So I'm increasing milliseconds one by one, but it's an assumption. It's like to keep the track. It's not real. So it can be different. It will be most probably different. And then we have a function definition. We are defining print data function. And afterwards, we are not going to execute console log because this is execution context of the print data function. And this is not triggered yet. So we will skip and we will run the console log prefix and name. So once we do that, we are getting our first console output at the 3rd millisecond. After that, we are running the print data function, which will execute the function so that we can go inside of it and we can run our code. Here, we have our new execution context. It has a memory, which has default value data, which is welcome, since we passed welcome value to the function. And it will run its code, which is console log data. And then we will get our next console output on the 6th millisecond. And finally, since we are done with this, we will remove it from the call stack and we can continue working on the global one. And we had just one line of code in the global execution context, which will run console log, welcoming our guests is complete, console log, and it's over. So this is purely synchronous, one thread executed script. We didn't do anything with the browser tasks. We didn't use any part of this. We will come to them with the other browser features that we will use in the upcoming snippets. The code snippet 2. So we have 2 functions here. There is a function in which we need to do some assumption. I didn't write the code inside of it because it doesn't make sense. We don't need to inspect that one, but think about a function which is doing some evil stuff. It's just fetching and it's just waiting. It's blocking everything. You cannot do anything else. And then we have our print data function. We have this fetch data variable, which we'll call this evil function. And then we will hopefully do some print data function. So here, let's start. The first millisecond, we are defining a function, print data on the memory. We are not getting inside because we didn't call it. The second function, it's written down to the memory. We are not getting inside because we didn't call it. The third line, fetch data, we are defining this variable. The value of it is undefined because we will start executing this one, and this function will be pushed to call stack. Let's do this. Here, now we start to execute this function, which will take a while, and we started doing this at the 3rd millisecond. So let's assume that it took 2000 milliseconds, which is 2 seconds. In this duration of time, we finished working on it. We got our data, which let's assume that it's returning Burak. We will remove this from our call stack, and then we can continue executing the other ones. But the problem is, for the 2000 milliseconds, we were blocked, and we couldn't do anything. User couldn't even type anything to the UI. Now, since it went out, we can now call our function, which is printing the data, and it will call the print data with Burak variable. And we will get inside of the execution context. We will define the initial value, which was passed as a parameter. And then we will give our first console output in the 2006 milliseconds. And we will finish the execution context. We will finish our last console log, and we are done with this. So it took us 2008 milliseconds to complete this snippet. But the worst part of it, to get our first console output, it took us 2006 milliseconds, and we blocked the thread for 2000 milliseconds, which is over 99% of the execution time. So let's continue to the 3rd snippet. This one is using a browser feature, which is setTimeout. It's not a function that we defined. So this will use something asynchronous with the help of the browser. So we have a pretty small one. We have this print hello function, we have the setTimeout, and we have this console log. Let's start. The first millisecond, we defined the print hello function. We are not getting inside. We are going to setTimeout function. SetTimeout function is triggering the timer feature of the browser. The timer feature of the browser will start to handle the task that you give to the you give as a parameter, and it will get 2 parameters. The first parameter is what do you want to do, and the second parameter, and when do you want to do. We want to do this after 1000 milliseconds. So initially, we will call the timer feature. The status of it will be unchecked because we are still at the 1st millisecond, and we have onComplete. OnComplete is basically print hello. It will call the print hello function. So since this will handle everything in the browser, we can continue working on our main thread, and we don't need to block our main thread, and we can execute our remaining code, which is console log first console output, and we will go to the 2nd millisecond, which is the first console output, and we will get our first console output at the 2nd millisecond. And now, still in the 2nd millisecond, our timer is unchecked because it will take 1000 milliseconds for us to finish that timer and run this function. And once we reach to the 1002 milliseconds, the timer will be checked. And since the timer is checked, we will push the print hello function to this queue, which is called callback queue. And these queues are working in one way. So the call stack is the priority. And if you have something inside the call stacks, even if you have thousands of functions here, you cannot take any of them. And since we are finished with the main execution context, we are free to take this one inside. We will put this to call stack. And once we call it to call stack, it will run the function. We will get inside. We will console log the hello. It will be given at the 1004th millisecond. And we will finish it. And the code snippet will be over. So the difference from the other one was we gave browser a function, a method to run, which was like the print hello function, and then we did our first console output. We did our stuff. We didn't block ourselves, which is a great functionality, which is thanks to the browser. It's not a thing that we implemented. So the 4th code snippet. This time, it's a tricky one. It's a code which doesn't make sense actually, because we have the same one actually, but the difference is right now we have this 0 here, which is a little bit weird because if you set timeout 0 seconds, it means execute it right away, but it won't work like that. So here, let's start. Print hello function defined. we run setTimeout, the status of it will be checked initially because the 0 milliseconds is passed already. But we will push it to the callback queue. And you can assume that, okay, we will run print hello right now before first console output. But it's not the case. Since we have stuff to finish in the call stack, and since call stack is more important than the things that we have in the queue, you cannot run this one. We need to finish our code first, which is the first console output. And then once you finish with the first console output, it will be removed from the call stack. And since the call stack is free, we can move print hello to here. Print hello will start to be executed. And then you will have the hello console output after the first console output. So it started before, it finished before that line, but still we cannot push it. So this snippet is to show why we cannot, like why the call stack is prior than the other ones. So here we have the fifth code snippet, which is the code snippet just before the one from the last one. So we have a function called JSON-response, which is like returning a response to an object which is usable by the frontend app, which has it also has a print data function. There is a fetch data variable which is doing some fetching, and then we have done methods to push some functionality to do what we want to do with the data. So here, let's start doing this. This is the first time we are fetching actual data by the browser features. So here we have this JSON file response, which is set to the memory in the first time. The second thing that we will do, defining the print data function. The third thing that we will do, defining a variable called fetch data. But this time it's a little bit weird because right now we will run the fetch function, and the fetch data's value, the fetch function does two things. First, setting a promise to the assigned value, and second, calling the XHR method, which will take some time for us to get the data back. So here, we will start fetching the data. Let's assume that this URL, this API will respond back in 200 milliseconds. Since we have this thing ongoing, we don't need to block our thread. We can continue doing our stuff because we are still in the global execution context. So since we don't need to wait, we will continue in the 30 millisecond to assign some stuff to our promise. So there is a function called then over there, which is a field of the printed data, fetch data variable, because fetch data is equal to a promise, and promise has three important fields, which are, the first one is the status, which says if it's fulfilled or unfulfilled, if it's continuing or not. The second one, the value, what will be the result one. The third one, on fulfillment, it's an array of functions that you will do once you are finished executing the code, fetching the data. Sorry, not executing the code, fetching the data. So here, since we run this then method, it's getting this function as a parameter and pushing it to the onComplete part of this data fetch. And once the data fetch is finished, we will run those ones. And then we are running it again. We are giving the print data function to onComplete. And then now we have two stuff to do on fulfillment array. We continue on the global execution context. We will have the console log, which is the first console output. We will write it down in the console in the 50 milliseconds. Still, we are waiting for the data. And after a while, the data will be fetched. And then we will push our stuff to microtest queue. This time, it's the microtest queue. The timer was being pushed to the callback queue, but this time, it's being passed to the microtest queue. So here, since we don't have anything inside of call stack, we will push them inside. We will run JSON file response. We will start its execution context. It will give its output, which is like an object, includes a name field, which is equal to Burak. And then we will close it. Now we have one printed data function. Our call stack is empty. The call stack will push it, will get the print data function. Microtest will be free. And then we will run console.log.name, and we will give our last console output, which is in the 207 millisecond. So right now, we did run some code, and we did some asynchronous stuff. with the help of the browser and with the help of the XHR feature of the browser. Okay, so this is the last code snippet. And as the one before, we will assume that this endpoint will result in 200 milliseconds, just like the one that I wrote here. Let's start executing this one. So the first thing that we do, defining print data function. Second thing, defining print hello function. Third thing, block for 3 seconds. So there's a function which is doing some kind of like a heavy task, which will take a lot of time. I wrote down a sleep function, which is like a dummy function, which is waiting for 3000 milliseconds, but you can assume that you are doing some kind of like a for loop or some kind of like a map inside of map and doing very heavy calculations, which you are not supposed to do, but you have it anyways. So we defined that function also to the memory. We will continue. We are running setTimeout function, which we got from the browser. And in the first in 0 milliseconds, we want to run print hello function. So we will call the timer feature of the browser. And then the status will be checked initially because we are waiting for 0 milliseconds. We push it to the callback queue. But now we cannot push it to call stack because we still have some stuff inside of the global call stack. And we cannot ignore those lines before pushing this one. So we need to finish them first. And here, on the 4th millisecond, we are defining a variable called fetch data. We are calling the fetch function. Fetch function will do 2 things. The first thing, creating a promise on the JavaScript side. The second thing, it will call the XHR functionality, which has an unchecked status, because at the beginning, it will be not resolved, but after a while, it will be resolved. And then, since we still have stuff inside of the call stack, we will continue executing the global execution context, which is the fetch data.then. And now we are pushing some stuff to our promise to execute once our XHR request is resolved. We are not done with the global execution context. We will continue doing that at the 6th millisecond. We will run our evil function, which is a really bad function, and it will run for 3 seconds. So until 3006 milliseconds, the UI will be blocked and we cannot do anything else. So here, we need to run this one. Since I said that like this call stack is lost in first out, we need to finish it first. We cannot continue running this one. Let's continue. At the 204th millisecond, since we assumed that this URL will return us data in 200 milliseconds, this XHR request will be resolved. Since it's resolved, we will push the stuff, the functionalities that we have to microtest queue. So here, we are in a really bad situation. We have our callback queue field, microtest queue field, we have our call stack field. Everything is like, we have lots of stuff to do. And how browser decides what to do at that point. So call stack is the most important thing. We cannot do anything until we finish this one. So we will need to wait until 3006 milliseconds to finish executing that one, and we remove it. Since we removed that one, the call stack will have global, and we can continue executing our code here, which is the first console output that we will get on the 3007th millisecond, and then we will remove the global execution context from the call stack. And once we remove it, it's free. And since it's free, we have 2 stuff to do, and we can move one of those functions inside of the call stack. But which one first? So here, for all of the browsers, if you have two things to do in both of those queues, you need to prioritize the microtest queue so that we will take the print data to call stack. And when we take the print data to call stack, we will run that function, which will give us a console log Burak at the 3009th millisecond, and it will finish executing it. We will push the print hello inside of it, and it will give the console log hello. And once it's finished, we will be finished executing with this function. So yeah, this was it. I hope I didn't expand my time too much. It was as far as yeah, it was a little bit fast one. Sorry, I was trying to keep inside of 25 minutes. If you have questions and if I have time, I would like to answer. But if you have questions and I don't have time, I will be over there to answer your questions at the next to table soccer.